Hey Mr. Melms, or whoever is watching this video, it's on YouTube. So I'm going to make this video as fun as possible just because it's 20 minutes long, and I know you gotta watch like 120 of these, so good luck, and let's start. Chapter 1, Essentials of Geometry. So basically I'm going to go over the big ideas of every chapter in this video, and I'll add in some fun stuff from now I am editing later. So this is a point, just a cute little dot all alone, has no dimension. Lines have one dimension and is represented by a line with two arrowheads and goes on without an end. Let's see here. There are any 2 points, there's exactly one line. Since it's already been like a minute, here's a plane, a segment, a ray, an angle, and a polygon. Gotta get this going or else I won't have time. So speaking of angles from earlier, we got two on screen right now, a complementary and a supplementary. Complementary angles are two angles that measure up to 90 degrees, and a supplementary angle are two angles that measure up to 180 degrees. And last but not least, congruent segments. They have equal lengths and congruent angles have equal measures. One chapter down. Okay. Chapter 2. Reasoning and proof. I'll start with using inductive and deductive reasoning. When you make a conjecture based on a pattern, you use inductive reasoning. An example of inductive reasoning is, the newspaper guy dropped off a newspaper at my porch this morning. So, the newspaper guy dropped off a newspaper at my porch this yesterday. Newspaper guy dropped off a newspaper at my porch this 2 days ago. Newspaper guy dropped off a newspaper at my porch for the past 2 years every day in the morning. So the inductive conclusion: the newspaper guy drops off a newspaper on my porch every day during the morning. Deductive reasoning Deductive reasoning you would use to show whether the conjecture is true or false by using facts, definitions, postulates, properties, or proven theorems. A real-life example of that would be all cars that burn gasoline create pollution. My car burns gasoline, therefore my car creates pollution. Then in this chapter is the thing everyone loves, proofs. Yeah. Logical arguments show a geometric relationship is true. In a two-column proof, you use deductive reasoning to work from given information to reach a conjecture you want to prove. Start with the given, the hypothesis of an if-then statement. Then there's your proof, the conclusion of an if-then statement. So if Mr. Mills gave me an A on this project, then I would be happy. The conclusion: I would be happy if Mr. Mills gives me an A on this project. That means you have to give me an A. Chapter 3. Parallel and perpendicular lines. Using properties of parallel and perpendicular lines. When parallel lines are cut by a transversal, angle pairs are formed. Perpendicular lines form from congruent right angles. So I'll pop you a little picture up there. Boop. Yeah. Then look, more proofs. So you can use the angle pairs formed by lines, and a transversal show that the lines are parallel. And if lines intersect to form a right angle, you know that the lines are perpendicular. Isn't that awesome? No. Chapter 4, Congruent Triangles. So chapter 4 is the start of the three corners. Fun. We have an equilateral, isosceles, and a scalene triangle. Then we got all our acute, equiangular, right, and obtuse triangles. Our equilateral triangle has 3 congruent sides. Our isosceles has 2 or 3 congruent sides, so technically it could also be an equilateral triangle. Scalene has no congruent sides. An acute triangle has 3 angles that are less than 90 degrees. An equiangular triangle has 3 angles that equal 60 degrees. A right triangle has 1 angle that is 90 degrees. An obtuse triangle has an angle that is greater than 90 degrees. Okay. Chapter 5. Relationships within triangles. So this chapter is a giant mouthful, and I mean giant, so I'll sum it up and show a few pictures. I got the mid-segment, perpendicular bisector, angle bisector, median, and the altitude. Yeah. The sum of lengths of any two sides of a triangle is greater than the length of the third side. In a triangle, longest side is opposite largest angle, and shortest side is opposite smallest angle. If two sides of a triangle are congruent to two sides of another triangle, then the triangle with longer third side also has larger included angle. Chapter 6. Similarity. Let me just say AB over BC equals ED over DC. That's just more triangle talk. Let me explain. Here's a triangle. AB is 5, BC is X, ED is 6, DC is 18. So plug all that in and you get 5 over x is 6 over 18. So multiply 5 and 18 to get 90. Then multiply 6 and x to get 6x. So 6x equals 90. Now solve x. What does that equal? Basic algebra. It equals 15. There's also other ways to do this problem, so I'll put them on the screen now. Now we got the AA similarity postulate, the SSS similarity theorem, and the SAS similarity theorem. Oh, and there's the whole awesome measurement system. You know, height of person over length of person, shadow equals height of a tree over length of tree's shadow. That's a mouthful. Jeez. Chapter 7. Right triangles and trigonometry. The Pythagorean theorem states that in a right triangle the state of the length of the hypotenuse C is equal to the sum of the squares of the lengths of the legs A and B, so that C squared equals A squared plus B squared. Sorry, my screen is a little messy. The converse of the Pythagorean theorem can be used to determine if a triangle is a right triangle. If C squared equals A squared plus B squared, then the measure of angle C equals 90 degrees, and triangle ABC is a right triangle. If C squared is less than A squared plus B squared, then the measure of angle C is less than 90 degrees, and triangle ABC is an acute triangle. Vice versa for an obtuse triangle. Now we move on to our special relationships. And right triangles. 45 degrees, and 90 degrees is one example of a special right triangle. Another example is 30 degrees, 60 degrees, and 90 degrees. And lastly, the big trig. The tangent, sine, and cosine ratios can be used to find unknown side lengths and angle measures of right triangles. Values of tangent x, sine x, and cosine x depend only on the angle measure and not on the side length. Longest chapter yet, I think. Chapter 8. Quadrilaterals. I don't like these. The polygon interior angles goes like this. The sum of the interior angle measures of a convex n-gon is n minus 2 times 180 degrees. The sum of the exterior angle measures of a convex n-gon is 360 degrees. Some properties of parallelograms consist of opposite sides being congruent. Diagonals bisect each other, opposite angles are congruent, and consecutive angles are supplementary. I used that term earlier. Last but not least, here's a picture of how you can classify quadrilaterals by their properties. Look at the picture. It's like somewhere on the screen right now. I might be taking up the whole screen. I'm pretty sure it is. Yeah. Chapter 9. I'll start with a translation, where translate a figure right or left, up or down. Reflection reflects a figure in a line. A rotation rotates a figure about a point. A dilation dilates a figure to change the size, not the shape. This chapter is definitely the easiest chapter in the book. Chapter 10. Properties of circles. This chapter consists of something super fun. Circles. I hate circles. We got our three angular relationships in this chapter. The angles formed of circles. The measure of angle ADB equals 1/2 measure AB. We got the angles formed inside circles. I'm just going to show a picture. And we got the angles formed outside circles, where the measure of angle 3 equals 1/2 measure of XY minus the measure of WZ. And lastly, we got our coordinate plane equations. Chapter 11. Measuring length and area. Lots and lots of formulas. I mean, look at all that. You want me to say all that and I can just show you the picture to read? Wait, can he read? I mean, he is a geometry teacher. Maybe he doesn't know how to read. I'll just assume he can. So that was a lot of formulas, am I right? Then we go back to our if-then statements all the way from the beginning. Lastly, we got our arc length and our area of sector. We're moving to circle business now, Mr. Melms. Get ready. The arc length is the arc length of AB over 2 pi r. Equals measure,
Voice correct.
Equals measure AB over 360 degrees. The area of sector is the area of sector APB over pi r squared equals measure AB over 360 degrees. Chapter 12, Surface Area and Volume of Solids. Our last chapter! Woohoo! Yeah. We got our Euler's theorem, F plus V equals E plus 2. F stands for face, V for vertices, E for edges. Then we got our surface area formulas and volume formulas. And by the way, the volume formulas for prisms, cylinders, pyramids, and cones can be used for oblique solids. Now we are done. I sure hope I got an A, and by the way, Mr. Melms, have a great summer. Adios.
Oh, and before you leave, I just totally forgot. I need to add factoring in. You mentioned this the other day, so here's a little factoring rules right here. It's basically explaining itself, but to find, let's start with the first one, example 1. To factor that out, you just find what adds up to positive 4 and are multiples of negative 5. So it would be plus 5, or it'd be positive 5, negative 1. So x plus 5 times x minus 1. So that's, just ignore this part. I'm gonna blur these out so you can't even see it. Huh. Um, and then example 2 is basically, it's with, this is where rooftop would come in handy. You do 3x squared, well, you just do 3x times negative 10, which is negative 30. Then you gotta find what are multiples of negative 30 that also equal positive 13. And you get, oh, 1 second. You get 3, you get 10 and 3. Yeah, you get 10 and 3. So, I'm sorry, this wasn't scripted out. 10 and 3. So 5, yeah, to get it like this, x plus 5 is 3x minus 2. You got 3x. Here, I'll just.
Okay, so let's see here.
Let me just white out something real quick. Don't look here.
Don't look here, let me change the big brush, you can't see it. Ignore these, ignore this stuff. We haven't learned this. Or, yeah. Alright, well I did an algebra, but for now, cross that out. Cross that out, oh yeah. Now we got that out of our way.
I'm going to explain how I do this. I'm going to change to a pen, this will be easier. Okay. So for x squared plus 4x, so you do, oh, let's see, I want to find the multiples of negative 5. So to find that, well, it's either negative 5, 1, or negative 1, 5. This is a weird looking pen, jeez. Okay, so it's one of these. But then you realize there's a 4x right here. Whoa, 4x. So now you gotta make sure these add up to positive 4x. So positive 4. What adds up to this? Negative 5 plus 1. And negative 1 plus 5. Ding, ding, ding. As you can see, the answer is positive 5 and negative 1. So x plus 5 times x minus 1 equals 0. Okay, now we're going to go over to this one down here. So 3x plus 13x minus 10.
So now, 3x times minus 10 is negative 8. Okay? Okay. So the, change pen color. 3x. So now the 3x. So we know, that's negative 30, we know that things are, 15 negative 2. Yeah, right. Yeah, 15 negative 2. So, basically, 3x. So we know 15 negative 2. 3x times, 1 second here, need to think.
Let's start here. So we got 3x. So we know it's negative 30. And we know the factors are negative 15. No, wait. positive 15, negative 2. We know those are the numbers. So 3x times x, because we got 3x squared, so we need to make sure it equals 3x squared. 3x times x plus 5, because 3x squared plus 15. We gotta basically get this out, so we got 15 and negative 2, right? So we do, I can't fit it in the camera. 3x times x plus 5 times, we know that's minus 10, so negative 2 times x plus 5, because that's negative 2x plus 5, so that's negative 10. So now we'll just start backwards here. This is way more interesting if we just start backwards. It's much easier to explain. Okay, so let's cross some stuff out here. Sorry, this is not working out, but I am going to explain this the right way, and you are going to understand. So wait, turn white, turn white, turn white. There we go. So let's cross out all this first stuff up here. We don't need that anymore. I hate brush. Okay, whoa, whoa, this is so cool. I usually never mess around with this stuff, so this is kind of cool for me. Whoa, whoa, whoa. Okay. Ow, ow, I hit my knee. Jeez. Okay. So, change the brush. We'll start backwards here. Well, first, since we know it's, let's just get this simplified out. The basic problem is 3x squared plus 15x minus 2x minus 10. There we go. That'll be easier to explain. So, do you see 15 and negative 2 equal negative 30? There we go. Now we're starting to make sense. So 15 and negative 2 equal negative 30. So we know these are the right numbers to put right here. 15, negative 2. So we know we want to use that in our problem. So we just separate them. And now we got down here 3x. So 3x, what times 3x squared is x plus 5. So is 15x. So we get, see, this would equal 3x squared, and then 15x. And then we got down here negative 2x, negative 10. We put it all together, it equals this whole problem. Oh, that was harder to explain, but the basic answer is x plus 5 times 3x minus 2. Because you know, if we got the same thing right here, then the x plus 5 would be our example. Then we know that's one of the things, and then we just add 3x and negative 2. Oh my gosh, this is so messy. I'll try to explain it better with some editing pictures and all that. So 3x minus 2. And the answer will be displayed on the screen since I'm really messing up this part. Hope you enjoyed this video. I'm so sorry for the very end, but it makes sense. May be messy, but in the end, it works. Now for my official adios.